Alright, what's up boys and girls? What we are going to be talking about in this video is, this is going to be the Statistics Unit 9 CRT Preparation Part 1. What this unit has to deal with is hypothesis testing. So again, what a hypothesis test is, and how we are going to be using it in this chapter anyways, is that there is an assumed average, like historically showing the average should be something. Now, so everybody just assumes that the average is true, alright? However, you can take a sample, okay? You can take a sample and, oh, maybe your sample shows a different average. And so is this sampling that you did, this minor sample, is this substantial enough to say, oh, this average is wrong, and maybe this average should be greater than what it says it is, or maybe it should be less than, or maybe it's not equal to, or something like that. And that's in essence what a hypothesis test is in this chapter. Now, there's three different types of problems that we can do in this. We're going to pretty much be focusing on this first one today, and then we can talk about these a little bit later. Alright, so in this very first type of problem, what makes this problem this type of problem is the fact that it has a standard deviation built upon a population. So a population standard deviation. And you'll know you'll have this type of problem because they'll pretty much say exactly point blank that you're dealing with a sigma. Okay, now this is a similar equation in this middle, but notice how the standard deviation is an S. So that is a standard deviation of a sample. So it'll be purely of the sample that you chose. And then these are probabilities. Anywho. As I said, today we are going to be dealing with this example right here. So what we have is, we're going to be doing two examples together, and then there is a third in which you have some homework questions to fill out and submit. Alright, so this is your homework right here. Alright. And away we go. Okay, so example 1. It says, a certain company sells fruit juice in cartons. The amount of juice in a carton is a normal distribution with a standard deviation of 3 milliliters. The company claims that the mean amount of juice per carton, the average, is 60 milliliters. A trading inspector has received complaints that the company is overestimating the mean amount of juice per carton, and he wishes to investigate this complaint. The trading inspector takes a random sample of 16 cartons and finds that the mean amount of juice per carton is 59.1. So it's supposed to be 60, but he took a sample and it's less. Okay, so is this wrong? Maybe this average is too big and it should be smaller than 60. Alright, so using a 5% level of significance, can the claim of the average amount of juice per carton is less than the claimed average to be substantiated? Alright, so here we go. So let's write down the important stuff. So what is the average supposed to be? The mu, the big average is supposed to be 60. And our sample average was 59.1. Okay, the standard deviation that we're dealing with is a sigma, and that is of 3 milliliters. Our sample size was 16 cartons, and a level of significance, it's the alpha, it's the fish-looking thing, and we are looking for a level of significance of 5%. How I begin these problems is I write down my hypotheses and the level of significance, and also kind of let myself, is this a left tail, right tail, things like that. Okay, so the null hypothesis is that the average is 60 milliliters. The alternate hypothesis, what is the question asking? Well, is the average less than that? This makes it a left tail. Kind of think of it as an arrow. And the level of significance, that alpha was 5%. Okay, this is a standard normal. And here we go, the one math problem in this entire problem, the z, which is x bar minus mu divided by sigma divided by the root of n. So this is 59.1 minus 60 of 3 divided by the root of 16. Alright, and what I'm going to do is I am going to just do this on my phone calculator. You don't need anything fancy. I'm going to do this bottom. So that's 3 divided by the root of 16. The root of 16 is 4. So 0.75. The top is 59.1 minus 60. Negative 0.9. So negative 0.9 divided by 0.75 is negative 1.2. Okay, no fancy calculator required, and we are done with the math portion. Okay, we use this right now. We developed this thing called a p-value. And our p-value is built upon this z of negative 1.20. So a z, we are using a z, so we need our z table. How we use the z table in this situation is we always look this z is equal to, always look this up as a negative, because we are interested in the area to the outside. So since this one is negative, we just keep it negative and we look up negative 1.20. However, if this were a positive number, we look it up as a negative. So always look this up as a negative. So here we have 1.20, so I look at my negative side of 1.20. That's 0.1151. That's my p-value. Okay, how do I use this and what does this mean? We draw our picture of our distribution, so normally distributed. The rejection, this is a left tail, so the rejection zone is on the left. That means this is do not reject H naught. And the gatekeeper between the rejection and the non-rejection is alpha. Okay. And you may recall, you can think of this p-value as kind of like a distance from the edge. Because this is a left table, we're going from the left-hand edge. So this distance right now to this gate is 0.05. Our p-value is 0.1151. 0.1151 is substantially larger than that. So our p-value is going to fall out here somewhere. Because the area to the outside is greater than that alpha. It's bigger than 0.05. Alright, so say that mathematically. So we just saw that our p-value is greater than our alpha. That means do not reject H naught. Means do not reject H naught. Well, okay, do not reject H naught. Big whoop-de-doo. Now, what does that mean and how do we write that in the meaning of this problem? So, enter our writing prompt. So when we do not reject H naught, how we begin to write is we do not have enough evidence to say. What do we not have enough evidence to say? We do not have enough evidence to say H1. So H1 in a nutshell is the average is less than 60. So we do not have enough evidence to say that the average and let's add context of the problem. So the average amount of juice per box. carton, I guess. Okay, so the average is less than. Average is less than 60. And that's milliliters. So just read it once just to make sure you don't sound like a yahoo. Okay, we do not have enough evidence to say that the average amount of juice per carton is less than 60 milliliters. So I still think that is probably less. It's just we do not have enough evidence to say it right now. Okay, it's not that we're wrong. It's just we need to get a better sampling. We need to take a better sample to get the results that we want to get. So that's what this one says. Okay, so that's our first example. We're going to go through another example, which is pretty much the same type of scenario right here. However, I think we're going to get different results. I think we're going to fall into that rejection zone. So we'll see the writing will change and our picture will kind of change. Everything up here will pretty much remain the same. It's just these two pieces will probably be a little bit different. So let's go ahead and take a look at that. In a men's cycling time trial, the times are normally distributed with a mean of 63 minutes and a standard deviation of 5.2 minutes. It is suggested that holding a time trial on a new course may result in lower times. To investigate this, a random sample of 25 competitors is selected. The mean time taken by these riders is 60.8 minutes. Using a 5% level of significance, does this sample prove the average time of the new course is less than the assumed mean trial time? Okay, so the average is supposed to be 63 of these courses. We took a sampling and our sample showed, oh, it's 60.8. So maybe this time, this average is actually smaller than 63. Is it less than 63? We have a sigma in this situation of 5.2. The size of our sampling was 25 riders. A level of significance, 5%. All right, so the null and alternate hypothesis. So the null hypothesis is that the average is 63. What are we thinking as our hypothesis? Well, I think that the average is less than 63. It's what the question is asking. This is a left tail with a level of significance of 5%. Okay, because this is a sigma, this is a standard normal. Okay, so the one math problem that we have here. So let's go with the bottom. So this is 5.2 divided by the square root of 25, 1.04. And the top, 60.8 minus 63. So negative 2.2 divided by 1.04 is negative 2.12. Okay, so this is going to lead us to our p-value. So our p-value is built upon a z of negative 2.12. So even if it wasn't negative, I'd look it up as a negative. So 2.12 is 0.0170. So our picture, this is a left tail, so my rejection zone is on the left. The gatekeeper is alpha. And again, think of that as a distance from the edge. So this p-value, if this is 0.05, is 0.01. Whoa, it falls short. So it falls in here somewhere. right? So the area to the outside is smaller, and so our p-value in this situation is 0.0170. Okay, so what does this just show? Well, we just showed that our p-value, and this is where the previous problem and this problem differ, is less than alpha. P-value is smaller than alpha. That means we reject H naught. Okay, so in the other one, do not reject H naught. Well, here is reject. We reject H naught. So if we reject H naught, that means we accept H1. Okay, so this is a little bit different than the previous problem. Still very similar, but a little bit different. Now, the writing prompt. What do I write when I have this answer? Well, this is literally what I write. I reject H naught, accept H1. So we reject H naught. H naught says the average is equal to 63. So we reject that the average this is a time trial, so trial time. So we reject that the average is equal to 63 minutes. Okay, so we reject H naught and accept H1, the average is less than 63. Again, just read it once just to make sure you don't sound like a knucklehead. So we reject that the average trial time is equal to 63. So we reject that the average is equal to 63 and accept the average is less than 63. Outstanding. Okay, so again, when we do not reject H naught, we do not have enough evidence to say H1. When we reject H naught, accept H1, we reject H naught and accept H1. Okay, here is your assignment. So it is a similar problem right here. And the problems that you have to complete down here correspond with this. So again, what these problems are. Question 1 is, what is the z? So if it were this problem, the first question is, what is your z of x bar? And so in my first example, that would be negative 1.20. So that's what I'd put for what is my zx bar. I would write negative 1.20 if I were talking about this problem. But again, you have your own problem right here. Next is, what is the p-value? So that I would write my p-value, so 0.1151. So that would be my answer to number 2. Number 3, what is your conclusion? Reject H naught, accept H1, or do not reject H naught. So in this one, I do not reject H naught, so I would answer that B. Do not reject H naught. And then this, you'll physically be able to write it in the program itself. It says, write a brief conclusion of your findings. And I would write, we do not have enough evidence to say that the average amount of juice per carton is less than 60 milliliters. That's what I would write for number 4. So again, you are answering the Z. The p-value is going to be A, reject H naught, accept H1, or B, do not reject H naught, and then physically write that. Those are your 4 questions for this portion of the homework.